Alright, hello all, hello world. Hopefully everyone is doing a-okay today. Yeah, this is day 84 of studying compilers every day until I land a compiler role. I'm like quite tired and I have a bit of a headache, so I'll try to keep today's stream a little bit short, but yeah. Yeah, so we're gonna be doing more tree gen today because we started that last time. It started to go well, and then we kind of just ran out of time. So, yeah, hopefully we can get this completely done today. If not, then like that's also perfectly fine. Yeah, so I guess it should be a pretty good time, I hope. Yeah, so let's look at the rest of the to-dos that we have. Where do we start? Okay, so we need to push color save registers. Need to push, wait. Oh, collie and color save registers. Maybe we need to figure out allocating stack space. I'm not really sure how I want to handle that yet. I might make a generic instruction that I guess handles that sort of thing, just as a bit of an abstraction, so I can think about it a little bit less. We also need to like generate the rest of like the call stuff. That we can leave. This we need to figure out. Yeah, I think we should be able to just like deallocate stack space as it turns out we need, so that should be fine. And yeah, I think that's kind of all we need. So the big pile is just like pushing and popping color and collie save registers. So that seems like it'll be an interesting pile to deal with today. Oh, what's good, Coastside Breeze? Good to see you. I appreciate the support. Okay, so let's move this over to a different file just for uniformity. I think it fits best in operand actually. Just kind of with like this whole pile. Yeah, kind of like here. And then let's do this. And then is this good? What's wrong here? ODR. Oh, yeah, that could cause issues actually, yeah. Okay, maybe I should make like a helper function here instead. So I guess let's throw this just in the C++ file real quick. I think this goes at the top. Yeah, so we're like here. Yeah. Write that. Okay, that fixes that. Okay. So I think we want a couple of helpers here. So like, let's do like, maybe we could do like a vector even actually. Because like we'll have like different calling conventions in the future maybe. So if I want it to be reusable, I think I should just do it like that. So let's do a stick vector of register. This is arg registers, right? Or get arg registers. We need to include vector. Whoops. Why don't I have vector here? Oh, right. I don't import anything here. Okay, so we want arg registers, and then we want collie saved, and then caller saved registers. Okay, I think that's the big pile. Do we invert this? And it doesn't matter. Okay, so let's throw this here. Support different calling convention. Looking at you. Windows. Okay. Got my obligatory everyone else glare kind of out of the way there. So we can return. I guess we can just take this initializer list and then reuse that. Yeah, I think we could. We could make this prettier even. We can just let's do edges equals, or is there a way to like make this initializer list not look ugly? What's the code convention for that? What does it look like usually? Well, this is not helpful. Okay, you know what? We're just gonna deal with it. Typing speed? Yeah, I mean, I'm getting there. Yeah, let's not do that. Let's do this. And then we can steal this. And then let's turn it on. Okay. Cool. So we can get rid of this now. So next is these two. So this we need to kind of do differently. So what was I looking up again? It was in here, I think. Sorry for the full blind. Let's turn on dark mode. Okay. Functions, preserve those, and these are scratch registers. So the scratch registers are, I guess, caller saved is the way to think about it. And then the ones that functions preserve are callee saved. So maybe we could, is there a better way to name it, I guess? I think this is probably fine. Okay. With rewatching, I mean, some days are slow. That's kind of just the algorithm. It is what it is. I don't really think too much about numbers. Those are caller saved. Whoops. But yeah, I mean, like, numbers are whatever at the end of the day. It's like, it's cool to see that there's a lot of people supporting me, but at the end of the day, I know of people that have like let it take over their lives before, so I do my best to ensure that doesn't happen with me. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7. Did I? Oh, right, duh. Wait. 1, 2, 3, 4. Oh. Wait. What? Wait, what do we do with RAX then? Oh, there it is. Wait, am I just blind? These are the same thing. I might be dumb. Okay, let's try that again. So those are the... So the other ones are function preserved, so those are callee saved. So these are the caller saved. Okay, that makes a lot of sense now. Whoops. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. We have the correct number of registers now. First try. So let's do the same thing here. So instead here we want REX, RDI, RSI, RDX, RCX, we have R8, and then 8, 9, 10, 11. I can't type. 5, 6, 7, 8, 9. Cool. Best resource to learn code from scratch as for you. I'm not really sure. There's a lot of different places. It all depends on what you want to learn, I guess. Like learning to code is just like very broad, so it's really hard to like give a good answer to that. If you want to like make websites, I think like to just like any sort of tutorial online about like on like JavaScript and like React, I think are a good place to start. If you want to like just like broadly learn how to code in air quotes and not really sure what to do with it, I think a good place to start is learning Python. The great thing about both of these is that since they're such popular languages, resources for them exist pretty much everywhere. So I don't really think I don't really think I need to like recommend anything. I think just like if you do a quick Google search, I don't think there's a wrong answer out of the pile that you can find there. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. So 7 plus 9 is 16. So we have the correct number of registers. Is there a way I can like make Clang format not yell at me? Maybe I just put it outside like this? And just like do it once. Yeah, so one there. Get this one. Wait. Okay, so that's Clang format on. And then we want off here. Okay, cool. First try. Yeah, of course. Let me know if you have any other questions. Speaking of which, if anyone has any questions when I'm off of stream, feel free to ask in my Discord. The link is in the description. You get to chat with me and the broader community outside of stream hours. You also get to, you also can like have a better place to figure out when I actually go live because YouTube notifs are quite poor. So yeah, that's my little pitch there. Okay, so what was I doing with all this again? I was updating gen trees. We already import operand, so we can just use this now. So yeah, so we want, so we need to figure out this still. So we want auto reges equals, or maybe we could do this in like a singleton sort of way. That might actually be smart. Yeah, I might do that. That seems smart. Okay, well, anyway. I think the dynamic size is kind of inevitable. So maybe we could like make these const ref, maybe? Yeah, let's do const ref actually. Or actually, wait. Const expr vector. Oh yeah, we can't do that. Wait, we can? Wait, what? Wait, that's a thing? Oh, that's really cool. Wait. Wow. Okay. Wait, I should read up about const exprs. Can I do a const expr function? Yeah, okay, I can do that then. That's really cool. Yeah, okay, that makes sense. Or actually, no, the function shouldn't be const expr. I don't know. Let's just do const refs. So we can do argreges equals args. So we want get arg registers. This should be arg reges. Okay. 102 on my DSA test today. Nice, good stuff. Yeah, DSA is quite important to get right, so that's really good to hear. Is type correct? No. I need to update in the thing here. So there should be a ref, const. This is a ref to look. Can I just like static regis equal? Let's just do static std vector register num. So if it's empty, then you can do this sort of thing. Then callie saved equals that. Yeah, let's just get rid of this Clang format stuff for a second. I think that's gonna make a mess. Final year of bachelor's in computer science, don't have much knowledge of coding, just confused. Should I pursue masters or learn C++, Java, DSA, or web dev? That's all up to what you want to do. If you want to just like if you want to get into web dev, I think it's really hard to give a recommendation just because software engineering is such a broad field. Like if you want to get into like systems or like machine learning, I think it probably would be a good idea to try to pursue a master's. If you want to just do like web dev stuff or like front end work, I think just like learning the language, like whichever language for whatever you want to do, is probably the good place to go. Yeah, okay, so we can do this. So we can do that, and then turn callie saved. Yeah, okay. Honestly, I'm not that bad. I'm not too much of a hater of this sort of, the way this looks. The Cheeto looking, the Cheeto colored name is not ideal, but it could be worse. Yeah, okay, let's get that. So this is caller saved. Const that, let's get a ref. So we can also do the same thing one more time. So let's just get rid of this real quick. Let's delete that. Let's paste this in here. This is kind of singleton-y, which is kind of what I'm going for. Because I might be calling this very frequently. Yeah, so we can do it like this. Yeah, okay. And then rename this to arg registers. So let's make this const. Okay, let me just double check with ChatGPT that I'm doing this correctly. I really hope I am. Is this correct C++ code for a singleton sort of implementation? Okay. Yeah, okay. This is basically what we want. Oh, wait, what? Doesn't... Oh, interesting. Okay. Oh, that's really nice actually. Okay, I'll do that then, yeah. Let's just do that. Okay. Wait, that's really nice. So we can do that, and then we can get rid of one scope level there. We can do that, we can get rid of that. Okay, cool. That's quite helpful, actually. What time in your degree or life do you feel like you had the skills to build meaningful things? I guess there's like two parts to the way I'd answer this. The first is that, like, just concretely, I feel like it took me until like after my sophomore year to, I guess, fully, or I guess like even halfway through my sophomore year to fully feel comfortable making things. But the second thing is, I think if you're asking this question to like kind of like benchmark, or like I guess like gauge how far you are, I think it's kind of asking the wrong question. I don't think there is necessarily an inherent time that you quote unquote like feel ready to make things. It's kind of just something that you have to like figure out for yourself just by like actually doing the thing. Yeah, like it's really hard to, I guess, it's really hard to like get a good sense of it without having just like made something. So if you're using this as like a should I build something or not, the answer should just be yes, you should build something. That is the best way to learn and the best way to feel more comfortable. And it doesn't even have to be anything good. It just needs to exist. Okay, I think this is sufficient for that. What type is this? This is const ref. It should probably be a ref, right? Yeah, okay. So we can do a ref to that. Yeah. Tar registers. Actually, let's just rename like that. I love LSP. Okay, so we have that now. Now we can, I guess, start filling in the rest of this. Yeah, so, I guess this is kind of interesting because I'm not sure if I need these right now. I'll need them later for sure. But for now, I could kind of just be lazy with it, I think. Yeah, we could probably do like a maybe push is kind of the instruction that I want to make. I think I should do like a maybe push and like a maybe pop. Because we can't really like figure out which registers we want to save without having done register allocation first. So I think it would be smart to save that for later. But yeah, I have some ideas on how I want to do this at least. So let's, alright, we should probably add like a phony instruction here, sort of like a fee as well. We should add like extra instructions that go in here. I guess how do I want to support those though? Maybe I should like, maybe at the bottom, sort of like here. Yeah. So we could, so I want something to represent a fee. I want something to represent a maybe pop and something to represent a maybe push, I think. I'll also need to like do something for like, I guess like managing stack memory, but that's something I can think about later. Do you use NeoVim and WSL? Yes, I'm running WSL Fedora because Ubuntu is not my cup of tea. Oh, I'm out of sticky notes. That's really sad. Okay, so you want I don't know, I guess I could call them, virtual's not the right word. I guess phony? Kind of like where fee comes from. Phony phony instruction. Yeah, okay, so we could do like phony. We can do phony, I guess. This looks so silly. So you can do that. Public. Let's just have this for now. I'll figure out the details for constructing this later. That's not really important to me yet. What I care about is phony push. And then phony pop. Yeah, so let's, I guess, yeah, so there's two ways I could do this. I could either just give it a pile of enums, or I could just make each of these kind of replicate these two, push and pop, I guess. Maybe I could just make it extend that. And that might be interesting. Or I could use it. Oh, wait. This might be the one time I could use a decorator. That's really funny. Maybe I do that. C++ decorator pattern. I've never used this in an actual project before, so this would be really cool if I had a chance to do this. Yeah, so let's do... Yeah. This is a terrible idea. I really shouldn't do this. I feel like I shouldn't do this. This would be interesting. Haven't gotten any offers yet. Heard the market was horrible for lower leverage level languages. I think it's about the same as it was before, to be honest. It's just like it's inherently difficult because not a lot of people want to do it. Yeah, I have an internship lined up for next summer, which I announced, but I'm not counting that as a role because it's not really full time. So I at least have something. Do I want to use the decorator for this? This seems like it's gonna be a very bad design choice if I were to do that. I guess what would change about this? I guess it would change the code gen. It'd be like I'd have to like indicate it somehow. Actually, that could be fine now that I think about it. But then how do I handle a fee at least? I might have to like make that explicit. Maybe I could do like I don't know. That's very interesting actually. I would have to handle them differently, which is a little bit annoying. I think for these we can just handle it as the underlying sort of type. See, this is like really... This is quite a conundrum. Okay. Let's... We could do phony fee and then like... Or we could just do like fee and then we can do phony, which is a decorator, I guess. I don't know. This is like not really virtual. I guess virtual might be the word almost. we could just do like virtual instruction and it's just a decorator. Yeah, I don't know. I think we can keep this explicit for now. I guess we could just make fee its own thing, and then we can do like a phony instruction here, and then we can see what we do here with that. And this will also be useful in the event I need to like also maybe generate other things as well, which could be interesting. Yeah, so let's do that, and then we need to define fee properly. So what does the node for fee require? I think it'll be the way to guide this at least. Yeah, we can just use this to indicate registers are the same, right? Or fee destruction in assembly. Or fee elimination. Whoops, SSA destruction. So we need copies or moves to do that. Okay, so we want destination register and then we want source registers, I guess, is how we should think about it. Yeah, so we want a... Yeah, so we kind of want to just steal this, I guess. We want destination. This should be... what type are we using? We're using operand star. So it should be operand star source. So then we can do this again. This is a fee. This is a... So this takes... Yeah, we should probably reorder this just to be consistent with ourselves. We don't have list? Wait, what? Why don't we have list? Yeah, okay. So this takes operand star destination. This also takes... Oh, bonk. Sorry, I got a notif. I'm getting sidetracked. Okay. So we want a list. So we can do that. I think that's good for now. We can write getters when we need them, but for now I think we're fine. Yeah, this is gonna be interesting to write actually, the phony. Maybe I make this wrap a unique pointer, and that might be the play. Yeah, we should probably do that. Yeah, I guess if we have errors in the assembly, we can resolve those as we see fit, but this seems reasonable for now. Okay. So this fee is fine. This phony we need to do a thing with. Or we could just do virtual instruction. We can make these a little bit better named. We can do this, I think. Okay. So then I don't know. What else do we want to add here? I guess we need a constructor for this. And this takes stood unique putter to instruction. Yeah. So we can paste this. Okay. We love Clang format, my beloved. Okay. GeForce driver, I don't care about you. Okay. I think that's all we need here. And then, oh, we need, or we could figure out how to do accept here. I guess we can define that later. We need to throw these in here though. So we need fee, and we need virtual. These get their own little box on the side because they are fake. They are definitionally fake. They are not real assembly. They are just, I guess, hints in a very interestingly implemented way. Okay, so let's do more of this. So we have this takes source is source, test is test. Can I just move this actually? Yeah, okay, that seems fine. That's just kind of a copy anyway, so I think that's reasonable. Yeah, okay. And then we want accept, which we can once again steal from above. Okay. Next one is instruction virtual. Let's just copy this. Yeah, so we can do that. So we can do instructions, stood move, instruction. Okay. This looks really stupid though, so I'm just gonna make this I. Okay, and then we can copy this. Okay, cool. Alright. So we have that implemented now. I think, is there an instance where we care about that yet? Or like the fact that we extended the thing, the visitor at all? I don't think so. Not yet, at least. Oh, but I'm not looking forward to that. Okay, so we can nodes merge. Yeah, we don't care about that in merge trees, so it's just tree gen now. We can take a second to think about again. Yeah, so we should, I was thinking about having like separate like push color saved and pop color saved, but honestly, I don't really think it's that important. So we can just work through these to-dos, I guess, and it will be pretty fair. Reach reg in get all the saved registers. So we want auto push equals stood make, we want to make unique. This is, let's clean that up real quick. So this should be our instruction push first. And this takes reg, and then What else does this take actually? Yeah, it takes a size as well. So this should take data, size. This should take quad word. And then we do that. What's wrong here? Size and then source. So, wait. Oh, wait, we need to make the register. Whoops. That's what I'm forgetting. Auto reg putter is so we have this operand manager thing, which is like this thing stores all of our registers in a sort of singleton way, so we can avoid clogging memory a little bit more, and then we can also keep that around. Yeah, so we can get register reg, or yeah, let me do that. How do I do it down below here? Oh, we just do source and dest. Okay. Yeah, we can do that. Okay, so we can do that. So we have the, I guess this will be source, I think we call it. Do that, source. And then auto virtual vert, I guess. This will be stood, make, unique, instruction, virtual. And this might seem insane, but I promise this is sensible to some degree. And this takes stood, move, push. Okay, and then instructions. I take this, we want to push that back. Oh, what the? Oh, I have caps lock. Whoops. Okay. So that's good. Yeah, so we push back a quote-unquote virtual register, which is like the push instruction, but we have it as like virtual, which means like we need to like resolve it in some way, I guess. This is just a term I completely coined for this instance, by the way, so don't take this as like gospel or anything. So let's go here, we can steal that, and then we can kind of use something similar here. Instead of callee, we can do caller save registers, and then we can do the same thing here. Maybe I could probably throw this into a, into some sort of a, what's it called? Helper function. Thinking about if I should. Yeah, let's make that actually. I think that will help readability because this code is already a nightmare to read. So this lives in tree. We want gen trees. Yeah, so we have these, and then we have or we want to push virtual registers is a little bit silly. Add virtual push. And then we can give that parameters real quick. This should take list of stood unique putter of LR instruction. And this takes a ref, so this is instructions, and then yeah, and then this also takes a what type is this? Oh, where am I? Stood vector of regnum. Yeah, like this. So this is registers. Okay. So we can do this, and then we can do virtual pop as well. I quite dislike this function signature though, so I might just not do this. Yeah, yeah, let's not do this actually. Let's go back on my word. Okay, so we have callee saved, and then we have the caller saved. So this is callee saved. We can do caller saved here. And then we need to do something sort of similar here with restoring them. Yeah, so this, instead of a push, we want a pop. And we can restore the full register like this. Pop. Yeah, okay. And then we can add those, and that resolves that, which is nice. Yeah, and then we need to do this here as well. Yeah, once again, instead of caller is callee. Okay. So we can do that. And then that solves some of our problems for the short term at least. 1, 2, 3, 4, 5, 6, 7. 7 to-dos left. Some of those I don't plan on resolving yet. Some of them I will try to resolve right now. We will have to see. I should probably add some comments in this because this is a jumbo function. Is there a... What is my plan for this? I don't think I need comments, honestly. My code should be readable enough. Alright, this is readable. Yeah. Yeah, this is readable, yeah. I'm trying to see if I can remove some white space in any of these. I probably can. Yeah, we should do that. Okay, how do I... Yeah, okay. Well, I think this is probably the least awful way to do this, I fear. Okay. So let's go back to fixing these. This to do I might need to leave. I need to think about how I want to do that. Okay, the call function label should not be that bad. Call equals we have a call instruction, right? Yeah, we have call. And then how did I plan on formatting the labels again? This is the... We want the function one, so we want the... Do we have the label that we make? Yeah, this just takes the function name, which is very useful. Yeah, let's do that. We can just give it the function name, which is very helpful. Okay, what does this take? This takes a label, so we can just give it... maybe we should, like, avoid the train car stuff that keeps happening, I swear. So... Actually, no. This is fine. We can do we can get callee, and then get name. Like that. Okay, cool. And then, or auto function name. We can delete this. we can do that. And then instructions, I'm gonna push that back. Okay. So we do that, and then next we want to move the return value into the variable. So we want move ret. This is another instruction. Yeah, so you move, and then this can just be, we can just move the literal register, I think. How do we care about register sizes for the virtual registers? I don't think we do, right? Like, we're kind of just working with, we're working with the 64-bit registers. Maybe I should add like a size to the virtual registers. Blessings, thank you. This is really annoying, actually. You can kind of just do it wrong for now, I think, surely. I've definitely done this before, yeah. So those we use the full register. Okay, I think the way we're gonna handle this is we're just gonna treat the virtual registers as a 64-bit register, and we will perform operations on them like they are not 64-bit registers, I guess. I hope that's not a very irresponsible choice, but we will find out the hard way, I guess. That's the fun of all this, right? Just all the poor design choices that I end up making. Okay. Yeah. So the move has extend. Oh boy. Okay. We can steal this stuff real quick. Yeah, so we can do like. This should just be none, I think. Actually, we can just, yeah, this is fine. We can just throw that in directly. So then we need source size, which is, these should both just be quad word, I think. Yeah, so we do that, and then we want the source and we want the destination. So source should be RAX, and then destination should be get the register. This should be I, or we should solve operand of I, or we want to. This just takes a value, so this should just be I think? It takes register, no, or... Yeah, it should be get register. Or, what is resolve operand? It's just an operand. Oh, wait, wait. This would just be resolve operand. Okay, well, we figured that one out, so I'm sure this will be fine. So this, we want source and then destination. So we want, oh boy, so we want, so it should be resolve operand, or no, it should be on get register. This takes LR register num. This is RAX. So we want source dest or dist. Okay, we figured all of that out. Yeah, okay. Maybe we should just like pull out source size and dest size as well, just in case. Lest I end up on Coding Jesus' channel. Yeah, we can do that. Okay. This seems reasonable enough. Yeah, this looks a little bit less ugly, so I'm happy with how that looks. Okay, so now we move the return value. We need to do that still eventually. Yeah. So 5 more to dos. This one I'll worry about eventually. This one I'll worry about eventually. This one I'll worry about eventually. This one I should do, and this one I'll worry about eventually. Any particular places where you'd like a job? I think like quant firms that support C++ development is the biggest place that would be enticing to me. Oh wait, I need to push back the instruction. Whoops, wait. I almost forgot to do that. Assembly or we want instructions, push back, of rent or stood, move that. Yeah, so that looks good. Sorry, the autos look like they were different colors to me. I might just be going insane. I know these are different colors. Interesting. Anyway. I don't know. I'm like tripping. But yeah, I think Big Tech would be a great place to end. So would Quant, to some degree, at least in terms of their compiler positions. Jane Street heavily contributes to OCaml. Yeah, that is one of the places I've looked. Also a bunch of other quant firms, most notably HRT, contributes a lot to C++. So yeah, that's the, I guess that's the dream end state at least. But also like Apple would be fun for their Swift compiler, or like NVIDIA's CUDA compiler. That'd all be pretty interesting to me at least. Okay, so let's generate the return. So auto ret. So this is a make unique. Yeah, this is just, this is a very trivial constructor. So you can push back, still move, ret. Okay, I think that's most of the stuff to do. Yeah, we've got 4 more to-dos in here. All of them I don't want to worry about right now. Yeah, I think this is fair. This is good enough. Do I need to allocate stack space for the pushes, actually? Let's ask chat. In system do I need to allocate stack space for a push? Okay, nice. That's helpful. So I don't need to worry about that. Preparing by having a project to show them? Not necessarily. It's nice to have on my resume, obviously, as just like one giant mono project that I've dumped a lot of I've just dumped a lot of hours into. But like also I just want to use this as a project to learn more about compiler design. My goal is to, at least in the middle end, reproduce a lot of what LLVM has infrastructure wise. So yeah, that's like roughly the goal. Asking about statics, 3 different behaviors. Yeah. I'm trying to remember what they were defined as. One of them was inside function. One of them was outside function. I don't remember the other one. I should probably look this up. Yeah, inside function. Oh, inside a class. Okay, yeah. That's the one I missed. Yeah, static for global makes sense. Static inside a function makes sense. And then inside a class is just like, yeah, I guess. This is kind of the odd one out almost. Yeah, I guess that all kind of makes sense, roughly. Okay. Let's commit some stuff. Oh boy. Gen trees has the most stuff. What was in here again? Oh, right. We have that. Okay, so let's... Oh boy. Let's add all the instruction stuff. Alright, let's add operand first. Add singleton. Singleton calling convention register reg lists. Static functions. If you're going to use a single translation unit, you mark your function as static and it lessens compiler time. Interesting. I guess that makes sense. Yeah, I guess, yeah. So I guess like static broadly, I don't know, would it be safe to say that static just like limits, or I guess no, we can't release a translation unit. Maybe we can actually. Is it safe to say that it just limits scope to current translation unit, I guess? But like persistently, I guess. I don't really know how to describe that. Yes? Okay, cool. I guess that makes a lot of sense. Like class static is class local, or class local, global, local. English is hard. Yeah, then there's like function stack and there's like file set. Yeah, okay, cool. Right. I've never been able to like think about how to explain it to people. Add phony instructions there. So fee and virtual. Forgot to close. Whoops. If you're not building one translation unit, it's the same thing as not declaring a stack, but less work. I see. That makes sense. Okay. This is add all tree gen things. Actually, I have an idea. I have a really, really bad idea, and does this exist yet? It does not exist yet. Okay, great. Is reflection in playing yet? Oh, it's in a fork. Okay, yeah. So it doesn't exist yet. I was thinking about using that to print because I was kind of lazy, but that would have worked. What is reflection? Oh boy, how do I even begin to explain this? Most simply, I think it's like runtime, I guess. Runtime type information, I guess. Reflection, C++. Yeah, if you've used like, I don't know how to explain it. Yeah, it's kind of like metaprogramming in a sense. I guess like using type info at runtime pretty much is the biggest understanding I have of it. But as it's obvious here, that is only one type of it, at least. There's also static reflection, which I guess makes a little bit more sense. But if you've ever like used like type of in Python, you've used reflection before. Yeah, I guess it's, the more I think about it, the less awful I think it is. But it's also like, people just like explain it in a very convoluted way. But I also think like, I don't know, like people have very strong opinions about reflection. I used to not really have an opinion. The more I think about it, I think it's fine to add, just because like, it's just like a nice tool to have in the event you need it for something. And like, I think it needs to be caveated with the fact that like in most cases it's kind of a noob trap, I think. Because it will necessarily be very slow. But yeah, that's my take, at least. Anyways, I think this is, let's make tests real quick. This shouldn't break at all. Unless I messed up somewhere at link time. Then it will break very catastrophically. Okay, it doesn't break. I have no use for it? Yeah, fair enough. Yeah, but just like, it's nice to know it exists at least. I think that's like the big flagship feature of C++26, if I remember correctly. Yeah, okay, so we can push this now. We don't actually test any of the backend stuff yet because I can't really test it yet, but it's at least like, it's at least a start. Yeah, so we built this, right, for the test, yeah, okay. Oh, wait, we need to build more. So yeah, I'm gonna see if this crashes, just out of curiosity. Let's run this, test, regression, input, if. Okay, well, it doesn't crash, which is ideal. Yeah, it's not supposed to print anything yet, so this is working as intended. What are you using to build? Yeah, I'm using CMake because I don't know why I'm using CMake. This was a terrible idea. CMake has given me so much trouble. It is just not worth the headache. Just use literally anything else. Yeah, CMake is powerful, but actually no. I did this to learn CMake, and in that sense, I was somewhat successful, sort of. If I were to do this again and like make a real project, would I use CMake? Hell no. CMake is like such a mess. The fact that, I don't know, there was like this talk that I watched about CMake, and it was like, how many directives are there? And like, everyone said like 30 or 40, and then the number was like in the hundreds, and it was like, what the hell? So yeah, CMake is not fun. Okay. I think, yeah, with all that out of the way, I think this is a good place to end the stream for today. What would you use instead? I think Conan is the big thing that I've heard of. Yeah, Conan build system. Yeah, this is like way more usable. It seems like actually like human. So I would use this. In your spare time, you should explore compiling to a single TU and build it with simple bash script. Yeah, that might be fun, yeah. I might give that a try. Yeah, let me add that to my projects list. But yeah, I think this is a good place to call today's stream. I think this has been like, what, just over an hour roughly. I've got some other work to do, and I also want to enjoy my evening like a human being. Yeah, I had my long shift of classes today, so I think I've done my time. Thank you all so much for showing up to today's stream, especially if you've been here this whole time. Make sure to like the stream if you haven't, and sub to my channel. It really helps out with the algorithm and gets my content out to more of you. And while you're down there, make sure you join the Discord. That's the best place to get pinged when I go live, and chat with the broader community during and outside the stream. And of course, you should connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. Yeah, I should make dinner, actually, yeah. I'm gonna make dinner now. Take care, y'all, take it easy, and have a wonderful rest of your day wherever you are.